So today we're dealing with elimination with addition. So to graph or not to graph, because that's what we've been doing. This is a system of equations, right? So how would I normally solve this system of equations? Solve for y and then graph it, and what do I know where my solution is? Where the two lines intersect, correct? So why would I not want to graph this one? Just by looking at it, why wouldn't you want to graph this one? Lena? Well, it's not in y equals mx plus b, first of all. So you'd have to solve for it first, right? Then you'd have to graph it. But what would make it not fun to graph? Anybody see it?
-20.
The -20. You could adjust your graph so that you'd have -20, but that's really far, right, Philip? And then -20 is really far from 4. So you'd have to be very accurate on your graph. What would be another reason not to want to graph something? Not just these two, but why would you not want to graph something? Nobody? Can you guys think of when you're graphing something, when it would not be fun to graph it? When it's a fraction, right? Because fractions, if I said, here's my solution, 1/2, 2. Is that really fun to go to only 1/2 and then up 2? No. And you don't get very accurate results when you're using fractions on a graph. Okay? All right, so that being said, pencils down. I'm going to use elimination. So my first step is to say to myself, I'm looking for inverses. I see that -5y and +5y are inverses of each other. So I'm going to eliminate them. Now I'm going to combine my two equations. Not a very straight line. I have 3 x's and 2 x's, so when I combine them I get 5 x's. 31 minus 16. 31 is about half, right? So 31 minus 16 is 15. So 5 x's equals 15. So how much would 1x equal? 3. So now, just like we were doing that number talk in the very beginning, where we had 2 numbers and they added to 6, and I told you, well, what if one of the numbers was 4? Would you know the other number? Yeah. How did you know that? It said they both added up to 6. So if one of them equals 4, we'd know the other one equals 2, right? Couldn't I do the same thing here? I know that x is 3, so how would I find y? I could substitute in 3, right? Which one would you like to use? I would use the bottom one. What are we trying to find here? When we're solving the system, what are we trying to find? We're trying to find where their intersection is. So if I have 2 lines, how many times do they intersect? Only once, right? So does it matter which line I use? Because they're both going to lead to the same spot when I find my solution, right? We're finding where they intersect. So I'm going to use the bottom one. So I have 2 x's plus 5 y's equals 31. And I know my x's equal 3. So I have 6 plus 5y equals 31. If I subtract 6 from both sides, I get 5 y's are equal to 25. So 1 y must be equal to 5. So what's my solution? 3, 5. My answer is not x equals 3 and y equals 5. My answer is 3, 5. That's on a graph, that would be where those two lines intersect, 3, 5. Only we're doing it without graphing. Question. Here's my steps. Identify possible inverses and multiply by -1 if necessary. I have inverses already, right? So I just need to get rid of them. Eliminate and add the two equations. So I eliminated my y's and I added my x's. Solve, I solved for x, and then I substituted x back into one of the equations and found y. Go ahead and copy that down. Okay, let's move on to the second one. Use elimination to solve the system of equations. So the first thing I'm going to do is identify possible inverses and multiply by -1 if necessary. I see that I've got y's in common. Can't I just grab the y's? The y's go together, right? 0 pair. They eliminate each other. So now I eliminate and add the two equations. So the y's are no longer existing when I add the two equations together. I have 3x and 3x left, which makes 6x equals 36. If 6x's is 36, how much is 1x, class? 6. Now I need to substitute. Which equation do you want to use? Top one? Okay. Why? Because it has all positives? Okay, so now I have 4y's plus 3x's equals 22. I know that x's are 6, so I'm going to substitute that value in there. So now I have 4y plus 18 equals 22. Now I just have to solve for y. Subtract 18 from both sides. I get 4y's equals 16. So 1y must equal 4. And my solution is? And what does that stand for again? Where the two lines intersect. Yes. No. Where did I get 16? Good thing somebody is paying attention, right? Or several are paying attention. Mrs. Miller's still not on her game. Good job. Thank you. First day without cough medicine. I'm doing okay. Thanks for asking. Okay, all right. I'm sorry? That's okay, I know. Not many people watch this, right? Okay, so 6, 1. That's where our two lines intersect, right? You've got two lines and they intersect at 6, 1. Should be moved over a little bit, right? So we're just going to make up, pretend, 1, 2, 3, 4, 5, 6, and 1. So you've got two lines intersecting here. All right, questions? Go ahead and copy that one down. Okay, let's look at the next one. Compare and contrast the following equations with your partner. Be ready to discuss your conclusions with the class. So look at these two systems and tell me what they have in common and what they don't have in common. Okay, can I get some volunteers on what these two systems have in common? Yes, Philip. Say it again. Okay, so they both, how about they both have, who would say they both have only two variables? Nobody? Who would say they both have 4 variables? Okay, now we got ourselves a problem. You got to pick one. Who would say that they have, this one right here has 2 variables? Who would say this one right here has 4 variables? Okay. So, this is what I would like. We're both right, correct? There are 4 variables here. But, are there really 4? There's just 2 sets of 2. Right? Okay. Are you guys confused yet?
Yeah.
Okay. So, I would like to say that yes, these are both, what they have in common. They're both systems, right? Specifically, they both deal with 2 variables. This one deals with an A and a B. This one deals with an X and a Y. Okay, let's talk about their differences. Yes? One of them has a variable that has an inverse to it, and the other one does not. Good. So how would I solve this one? We'd identify our inverses, cancel out, and use elimination, right? What about this one? Yes, we would make it into an inverse. So let's do that now. All right, so let's try this one. I've got 9s plus 2t equals 22, and 5s plus 2t equals 6. My first step is to identify possible inverses. There are none, but there's a possible one. Which one's the possible inverse? The t's, right? I've got a positive 2t and a positive 2t. Well, if this was a negative 2t, then we'd be able to eliminate. So let's make it negative. Let's multiply everything in this bottom equation by a negative, or the opposite. So what's the opposite of 5s? And what's the opposite of 2t? And what's the opposite of 6? Negative 6. So I'm just going to take a picture of that and replace it. Done. Now solve. Okay. Levi? You can share. Ready?
Yeah.
Give you 2 minutes. Michael, get a marker and do your own. Andrew, I don't see you writing anything.
Read the smaller, read the color.
I wouldn't. We still have a closing thought. Okay, about 30 more seconds. Ten seconds. I only have 8 answers in. About 30 more seconds. Andrew, why are you still not doing anything? Go get another marker. Okay, so what did you learn today? Elimination. Why? No. The shuffling needs to stop. Just pay attention. Why is it necessary to use elimination? You can't, because sometimes it's not possible to graph, right? Or it's just, it's easier to use elimination than graphing sometimes. Sometimes you may want to graph. The person next to you is absent. How would you explain why we sometimes need to multiply an entire equation by -1? Because we need inverses. On your assignment sheet, here's your system. In order to solve the system of equations, first I would blank, then I would blank. What would you do first?
Multiply by -1.
Change one of them, entire one, to negative, or the inverse, right? And then what? Then what would you do? I would eliminate next, right? Find inverses, then eliminate. Good job, guys.